Now, following on from the chapter that we have just finished, coordinate geometry of the line, we're going to move straight into coordinate geometry of the circle. And I will preface this chapter by saying everything you learnt in the previous chapter on the line still stands in relation to coordinate geometry of the circle. So all the different formulas, particularly focus on the two words parallel and perpendicular, because they will be extremely important. You carry everything you learnt in the previous chapter into this chapter here, and you will be applying certain formulae that we learned in relation to coordinate geometry of the line in terms of questions based on circles and the relationship circles have with various other objects that exist around them. Okay, so just to give a small bit of introduction in terms of the terminology that's going to be involved. The circle, first and foremost, is a shape we all recognize as being continuously curved. Okay, no beginning, no end, it's continuously curved. That continuous curving line is called the circumference. And the circumference, you would have learnt in junior cert, has a formula, because the circumference is a curved line, so therefore it has got length, okay? And the length of the circumference is 2 pi r, which means that the length of the circumference is dependent upon that letter there, or which stands for the radius. Now, what's a radius? A radius is any line that begins at the center of the circle and moves out to touch the circumference at any point. Now, because the circumference contains an infinite number of points, we simply say that every circle has an infinite number of radii. Okay? If you double the radius, you end up getting a diameter. But there's another way to explain the diameter, and here it is. A diameter is any line that goes from one point on the circumference of a circle to another point on the circumference of a circle, but it must also go through the middle. All right, and there's a third way to describe the diameter. It's the longest line inside a circle. It's the line that joins the points that are furthest apart from each other, and that will always be your diameter, which in its most simplest form is simply 2 radii. Okay, now the radius and the diameter, because they touch the circumference, there is another relationship, a very, very important relationship we have to talk about in terms of this red line here, which we call the tangent. We all know what a tangent is. A tangent is a line that touches the circumference of a circle once, and once only. Okay, that's what makes the relationship between the circumference and the tangent so unique, is that there's only one point of contact. All right, but at the point of contact, if you take a look at this diagram here, take a look at this radius going from this point to here, you will notice that at the point of contact where the tangent is, there exists a right angle. And in fact, every single type of tangent that you could draw to this circle, of which there are an infinite number, each one of those tangents has a unique perpendicular relationship with an individual radius. Okay, now keep that in your head. That's extremely important. Every single tangent has, at the point of contact, a unique perpendicular radius. So therefore, the one thing I want you to remember going on is a radius will be perpendicular to a tangent where? At the point of contact. And that's extremely important, because that comes up all over the place, and that's going to get you out of huge trouble in certain questions in terms of the slopes of both. So if we know that the tangent and the radius are perpendicular, what that means is that the slope of the radius will simply be equal to the slope, the negative inverse, minus 1 over mr, which will be equal to the slope of the tangent. So what I'm trying to say to you there is that the slope of the radius and the slope of the tangent are negatively inverted. All right, or another way to say that, when you multiply the slope of the radius by the slope of the tangent, you will always end up with minus 1. Now that's extremely important, because that is a mathematical identity that you will be using quite frequently throughout this particular chapter. Two other lines that we have drawn on this diagram here, the secant and the chord. Now what's the difference between them? You'll notice first of all that a chord joins one point on the circumference to another point on the circumference without going through the center. Okay, that's all that a chord is. And what's a secant? A secant is a line that intersects the circle at 2 points. So the tangent cuts it once, a secant goes through the circle and it hits it in 2 different places. Again, not going through the center in this case here. All right, so the chord, it joins 2 points on the circumference. The secant intersects the circle at 2 points. And don't forget, any line that intersects the circle at 1 point is a tangent. So the difference between a tangent and a secant is that the tangent will have 1 point of intersection, whereas a secant has two lines of intersection. Now I do that terminology just in case it does come up in parts of the questions of this chapter as we move along. We must be familiar with the chord, with the circle, and all the various different lines that are related to that particular circle. Okay, so first of all, what is the circle in its most basic form? A circle has two things that identifies it. Number one, it has a center. Okay, so if you take any circle, there's always going to be a central point. Okay, and number two, the distance from that central point out to the circumference is a unique radius. So every circle has a unique center and a unique radius, and that is what differentiates one circle from another. At its most basic, and if we take this example here, at its most basic, we could place the center at 0, 0. And if that's the case, then that would have the most basic form of equation. Okay, but you can also place your center away from 0, 0, which just increases the complexity of the equation a little bit, not by much. Okay, not by much at all. So the most basic form is where the center is at 0, 0. But what I do want you to know from this diagram here is that the most important measurement in any circle is the length of the radius. Now that's down here, the position and the length of the radius. That's there and there. So the length of the radius is the most important measurement, and also the position of the center needs to be known. So they are two things that you will continuously refer to whenever you're dealing with any circle. Where is its center? How long is its radius? And because a radius is a line, then that can be brought back into the previous chapter where we have the distance formula, where we have the slope formula, etc. And all of that can be applied to the radius because it is a line with its beginnings at the center of the circle and its endings at some point on the circumference of that circle. So moving forward, please remember, for every circle, the two most important things that you must identify, and I would always identify them, are the center and the radius. And you might ask, well, why is that important? Because there are three forms of equations that can represent a circle, and it all depends on where the center of the circle actually is. All right, so here are the three. I'm going to give you the three together, and then we're going to go through each one separately, and I'm going to set a few questions on each one as we move along, and then set a group set of questions at the end that you can work away with over the next day or so. So first of all, the most basic type of a circle is one that has its center at 0, 0, and it has length of radius, which we're just going to simply call r. If that's the case, then the equation of the circle is simply x squared plus y squared equals the length of the radius squared. Okay, that's all you've got to remember. So if you look at a circle and you identify the fact, oh, its center is at 0, 0, then you know immediately what its equation is. You know the form of the equation, x squared plus y squared equals r squared. If you can work out the length of the radius, then you know its equation, because all you've got to do is square the radius and put that in as the constant after the equal sign in the equation. Okay, so that's the first one. If a circle has its center at 0, 0, radius r, the equation will always be x squared plus y squared equals r squared. Now, next question is most logical. Well, what if its center isn't at 0, 0? What does it look like then? Well, it looks like this. If the center is anywhere else except at 0, 0, we call the center hk. And again, we give it a length of radius, which we're going to call r. If the center is at hk, then these two values must be put together with the x part and the y part of the previous equation. Okay, so because it has moved away from 0, 0, we have to take into consideration the coordinates of the center. And here's what we do. We take the value of h and we put it in with x with a negative sign. So x minus h to be squared. And then we take k, we put it in with y with a negative sign. So we change its sign. Whenever it goes into the brackets or out of the brackets, it changes its sign. Okay? So you take h and k. The h will go with the x because it's the first of our named coordinates, and this one will go with y. So it's x minus h to be squared plus y minus k to be squared equals r squared. And that's the only change we have in terms of this formula here. So look, if there's no x and no y, then you leave the x squared and y squared alone. But if there is an xy value, i.e. if the center of the circle is away from 0, 0, then those coordinates of h and k must be tucked in here with the original x and y. And when they go into the brackets, they change their signs. And when they come out of the brackets, they change their signs. Now, what is lovely about this equation here is that if they give you an equation in that form, the center and the radius are readable. So what I mean by that is, if you take this equation here, the number that is after the x and the number that is after the y are the negatives of the coordinates of the center. So if I was to take out the h and the k and change their signs and put them together, that would give me the center of the circle. And how would I get the length of the radius? Well, if the last coefficient here is the radius squared, then the square root of r squared will give you the length of the radius. So we can work these things forward. We can build these equations, or we could be given these equations and asked to work backwards and reveal what the center is and what the length of the radius is. But more about that later. Now, the last one is simply this formula here expanded. Okay, and that's what I want you to remember. If we were to expand this formula, we would get another equation which would look something like this. X squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now what I want to say straight off is this. In these two, the center is readable. You can see the center. If there is no change to x squared and y squared, then the center is 0, 0. If there is an adjustment to x and y, then the adjustment of minus h and minus k is the negative of the coordinates of the center. And lastly, if they give it to you in this form here, well then the center is hidden, okay? And the center is hidden in these two terms. Because if you take both of their coefficients, the 2g and the 2f, if I want to work out the center, I have to first of all take the coefficients of x and y, I must halve them and change their signs. So therefore down here you'll notice I've written the center of the circle in this form is minus a half of the coefficient of x, which becomes minus g, and minus a half of the coefficient of y, which becomes minus f. But there's even another formula. Now these formulas, by the way, these are all on page, if I remember correctly, they're on the coordinate geometry page of your tables. It should give you the page number, I think it's number 19. Yep, they're on page 19 of your tables, at the bottom of page 19. Okay, so just make a note of that here. Tables, page 19 at the bottom. That's where you'll get this formula here. The radius you cannot read out of the equation. In this form, the radius has to be calculated. Okay, and the way in which we calculate it is, once we have discovered the center, we square the first part of the coefficient, which is g, so you square minus g, you square minus f, and then you take away the final constant here and get the square root of the result. So the radius formula, when it's in this form, is g squared plus f squared, where g and f are the coordinates of the center, minus whatever final coefficient they have given you in the original equation. And when you get g squared plus f squared minus c, and you get the square root of that, that will give you the length of the radius. So, moving from this table, and don't move off this slide until you know those three formulas. Here we go. If a circle has center at 0, 0 and radius r, its equation is x squared plus y squared equals r squared. If the circle has its center anywhere else except 0, 0, call it hk, then the equation will be x minus h to be squared plus y minus k to be squared equals r squared. And finally, if we take that equation of x minus h to be squared plus y minus k to be squared equals r squared, and we give you the expanded version, then we give you a version of the equation which kind of hides the center and hides the radius. And both of them need to be calculated. This equation here, you'll take the coefficient of x, you'll take the coefficient of y, you will halve them and change their signs. That will reveal the center. But in order then to find the radius, you must use the coordinates of the center, square both values at the center, so square your g and square your f, then take away any constant that is at the end of the original equation and get the square root of that particular sum. And that give you the length of the radius. Now we're going to practice this as we move along. So what I'm going to do now is I'm going to take each one of these formulas individually just to show you one or two examples of how we use them, and then I'm going to set some questions for you to do in relation to these three formulas. Okay, so let's take the first one. If the circle has its center at 0, 0 and it has length of radius r, its formula is x squared plus y squared equals r squared. Now we can do two things with this. They could give you the center 0, 0 and the radius of length, say 4, 5, 6, whatever it's going to be, and ask you to build the equation. Or they could give you the equation and ask you to reveal the center and the radius. Now either way, you've got to be able to work both ways with these formulae. Okay, so let's take an example like this one. What is the center and the radius length of a circle whose equation is x squared plus y squared equals 169, and then 16x squared plus 16y squared equals 25. Okay, they're giving you the equation. Now you have three equations to pull from. Is it the one where the centre is at 0, 0? Is it the one where the centre is at hk? And is it the one where the centre is masked by 2gf and or 2gx and 2fy? Well, in this case, x squared and y squared have no adjustments. There's no mention of h and k, there's no mention of g and f, so straight away the centre will be equal to 0, 0. The centre will be 0, 0. And the radius is equal to, now what I would sometimes do here is I'd write down the formula that this is based on. It's based on x squared plus y squared equals r squared. So that means that r squared is equal to 169, which means r will be the square root of 169, which is 13. So your centre is 0, 0, and your radius is 13. Okay, part 2, and I picked part 2 for a reason. If you go back to the 3 equations we had a moment ago, let me just jump back quickly to this one here. I want you to take a look at something. X squared plus y squared. See that? X squared plus y squared. X squared plus y squared. The only coefficient of x squared and y squared that is allowed is 1. So when we go to the question I've just given you there a moment ago, you'll notice that this is starting off as 16x squared plus 16y squared equals 25. No equation of any circle, if we're working with it mathematically, is allowed to begin with any coefficients of x squared and y squared except 1. So the very first thing I'm going to have to do here is to adjust this into a readable form. And that means I've got to divide it by 16 to get the x squared and the y squared down to the readable form of x squared plus y squared. Now I've got to divide everything by 16, so that becomes 25 over 16. And then you ask yourself again, what formula is this based on? Well, this is based on x squared plus y squared equals r squared. So straight away, my centre is 0, 0. Now you might say, how do you know that? Because look, there's no mention of h and k, there's no mention of g and f. So if there's no mention of h and k, no mention of g and f, then the centre is 0, 0. Okay? And r squared, you see it there, r squared is equal to 25 over 16. Now what that means is I've got to get the square root of both sides. So if I get the square root of r squared, I get r. And if I get the square root of 25 over 16, just get the square root of both numbers. That will become 5 over 4. And leave your answer as a fraction. Leave it as 5 over 4. Don't write down 1.25. Don't do anything. Just leave it as 5 over 4. Okay? And a word of warning for maths. Don't use decimals unless they actually explicitly ask you for decimals. Use fractions and then clear the fractions. It's a much, much easier way to keep the math simplified. So if fractions come out in your answer, leave them as fractions. Use them in the question, and at the first available opportunity then, you can clear them straight away. Okay? So, that's the first part of that. Now let me just clear that because there's another question I think underneath this one. So that's how you read the equations. Now, if they give me, I'm just going to clear this, I think there is something else underneath this. If they give me the centre and the radius, and they ask me to give back the equation, which I think I have coming up next, what do I do? And the answer is you just put them into the formulas. That's it. So you're moving forward with 3 formulas. X squared plus y squared equals r squared if the centre is 0, 0 and the radius is r. X minus h to be squared plus y minus k to be squared equals r squared if the centre is hk and the radius is r. X squared plus y squared plus 2gx plus 2fy plus c equals 0 if that's the expanded version, the full version of the equation of the circle. Okay, well, there wasn't any questions on that. That's grand. So, before we move on to the next part, I want to take a look at this. And I've spoken about this already. What is the relationship between a tangent and a radius? And again, I'm just going to point out to you that when you have a tangent is a line that touches the circumference at one point only. And at that point of contact, there exists a perpendicular radius. So tangents are always perpendicular to the radius, which means that the slope of the tangent multiplied by the slope of the radius is equal to -1. Or put it another way, the slope of the tangent is equal to, or is perpendicular to, I should say, -1 over mt, so the negative reciprocal of nt, which is going to be mr. Okay, so just keep that in mind. That's extremely important in terms of what we're going to do moving forward. We'll just put that perpendicular sign in properly there. So the slope of the tangent is perpendicular to its negative inverse. And the negative inverse of the tangent formula is the slope of the radius. There are two things that you have to remember. Okay, so this one here will have a slope of r, and this one here will have a slope of t. So just keep that in mind. One final thing that I want to point out before we move forward is this. If you're asked, where does a circle cut the x or the y axis? Now, we've had this in coordinate geometry of the line. Anytime anything hits an axis, you first of all ask yourself, what axis have I collided with? So if I have collided with the x-axis, you remove all references to y. Because on the x-axis, there is no y. Another way to say that is, on the x-axis, y will always have a value of 0. If you collide with the y-axis, you remove any reference to x. Because on the y-axis, there is no x. Or another way to say that, on the y-axis, the x value is always 0. So therefore, if they ask you, where does a circle hit the x-axis? Where does this circle hit the y-axis? Whatever axis you're dealing with, you remove the reference to the other axis. So if it's hitting x-axis, remove y's. If it's hitting the y-axis, remove x. And then just deal with the remains of that particular equation, which will be written in one term only, and therefore they can be solved. Okay, so just an example here quickly. When we wish to discover where a circle cuts the x-axis or the y-axis, we only need to remember something we've dealt with already in the previous chapter, and here it is. When you're working with the x-axis, there will be no y. And when you're working with the y-axis, there will be no x. Okay, so in other words, when you're working with the x-axis, switch off the y. So look at the equation, pick out all the y parts, see what's left in terms of x and solve it. And if you're working with the y-axis, switch off the x. Meaning, if you're working with the y-axis, take out all the x bits, see what's left in terms of y, and solve that one. So keep those two things in your heads as you're moving along. The tangent and the radius relationship, which is perpendicular, and then the relationship a circle has with each of the axes, which is a very simple thing of simplifying the equation based on which of the variables you're going to remove and which one you have to solve for. Okay, time for a few questions. Let's take a look at this. Now, this is a work example in your book, okay? So I'm just going to go through it here. The same solution is in your book, but I'm just going to do it here from the point of view, wanting to point out exactly what we have to do. Find the equation of the circle with center 0, 0, which has the line 2x minus 3y minus 6 equals 0 as a tangent. Now, when I'm doing questions in relation to the circle, I love to be able to draw them to see what they look like. Okay, sometimes it does help an awful lot when you draw these things. So what let me ask you to do? Find the equation of a circle whose center is 0, 0. Okay, so let's just take a look at something like this. Whose center is 0, 0, and which has the line as a tangent. Now, you know already what a tangent is. A tangent touches the circle once, and that's 2x minus 3y minus 6 is equal to 0. Because the circle has center 0, 0, I already know the equation. I know it in its general form because it's x squared plus y squared equals r squared. That is the only formula we can use when the center of the circle is 0, 0. See that? So when you know the center is 0, 0, that is what I'm going to use. So in other words, that's the equation. Now, there'll be no interference with x and y because x and y are 0, 0, but we've got to get the length of the radius. And I want you to take a look at this very carefully. The point 0, 0 and the tangent have a relationship between them. If you join 0, 0 to the point of contact, you get a radius. And as I told you already, a radius is always perpendicular to a tangent. Now, what does that mean? In this question, we have a point which is perpendicular to a line. Go back to the coordinate geometry of the line chapter. The distance between a point and a line is given a formula. It's the perpendicular distance. And the perpendicular distance is the absolute value of ax1 plus by1 plus c over a squared plus b squared. So in other words, if I want to work out the length of the radius, that's all I have to do here. I have to work out how big is the radius. I'm not going to touch x squared and y squared because the center is 0, 0, but I do need to know the length of the radius. Now, in this case, what is the radius? The radius, as you can see from my dotted line, is the distance between the center and the tangent. So, because that dotted line there represents or reveals a radius, the length of the radius here being perpendicular to that is going to be revealed by the perpendicular distance formula. Now, what's A, B, and C? A, B, and C are the numbers in the equation of the line, 2, 3, and 6. What's x1 and y1? They happen to be the values of the point. So in this case, x1 is equal to 0, y1 is equal to 0, a is equal to 2, b is equal to minus 3, and c is equal to minus 6. And I got all that from here, okay, from that diagram. Now all I've got to do is fill them in. So what's the perpendicular distance? The perpendicular distance is ax1, 2 times 0, gone. by1, gone. Plus c, which is minus 6, all over the square root of a squared, which is 4, plus b squared, which is 9, giving me the absolute value of minus 6 over the square root of 13. Now, remember what the absolute value means? The absolute value simply means that you take the positive aspect. So even if the number inside the two straight lines is negative, you take it as positive. So therefore the answer is 6 over root 13. So what have I got to do now? That also happens to be, so therefore, if that's the perpendicular distance, look at the diagram. The perpendicular distance is also the radius. So the perpendicular distance equals radius, which is 6 over root 13. So what have I got to do? Bring this back up to this formula here and shove it in for r. So you're going to get x squared plus y squared equals the radius squared. Just square the top and the bottom. 36 over 13. Leave it alone. Don't turn it into a decimal. Leave it as 36 over 13. Okay? Or what you could do, as I've already told you, is when the fraction appears, clear it. So you could multiply everything across by 13 to get 13x squared plus 13y squared is equal to 36. That's perfectly fine as well. So again, you're pulling from the previous chapter. In order to get the length of the radius, I had to figure out first of all that the distance between the center and the tangent happened to be the radius, and the radius happens to be perpendicular to the tangent, so therefore the length of the radius was the perpendicular distance from 0, 0 to that line, and that's why that formula came in so handy there. Okay, another question. The line segment that's joining A minus 3, 4 and B 3 minus 4 is the diameter of a circle. Find the center of this circle. Now, that brings us back to the previous chapter again, because if you take this, for example, and again, diagrams always help with these things. If that's the point, and it doesn't matter where you put the points, by the way, this is just reference for yourself. If that's the point minus 3, 4, and this is the point 3 minus 4, I want to find out who's at the center. I think you can guess. Yeah? Let's see what the center is. Now, what have we got? We have the midpoint formula. If you go back to the previous chapter dealing with a line, the distance between minus 3, 4 and 3 minus 4 is a line. Halfway along that line is the center of the circle I'm looking for. So the center is nothing more than the midpoint of that line that's inside the circle. And let me just remove the circle to show you. So let's just get rid of that. Okay, so that's what we're dealing with. Whoops. That's what we're dealing with. So I'm going to use the midpoint, and the midpoint formula is going to give you the center. And the midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2, which is going to give me minus 3 plus 3, 0, 4 minus 4, 0. Oh, lo and behold, surprise, surprise, center, 0, 0. Now, once I discover the center, I know the equation. So immediately I'm going to write down here, the equation is of the form x squared plus y squared equals r squared. And I know that because I've now discovered the center is 0, 0. Okay? Find the radius length of this circle. Now, if I want to work out the distance between the center, which I now know is 0, 0, and any of the endpoints, both of those are radius. So that's a radius here, r, and that's a radius. So if I want to get the length of the radius, you just take these 2 points here. That's it. So use these 2 points in the distance formula. And the distance formula, as you already know, is equal to the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. That comes from the previous chapter. Okay, so let's fill them in. What have we got? x2 minus x1. So x2, 3, minus 0 is 3, so that's 3 to be squared, plus y2 minus y1 to be squared, which is minus 4 to be squared. So that's going to give me the square root of 9 plus 16, which is 25, which comes out as 5. So now I know the radius length. So write down part 3, write down the equation of the circle. Well, there it is in general form. Because the centre is 0, 0, you leave x squared and y squared alone. There are no values to interfere with them. And you simply square the radius back up to 25. And that's the equation of the circle. Okay, now you need practice on that, all right? So I've put some questions down here, page 294, questions 6, 9 and 10, which deal with just using what we would say are the basic formulas from coordinate geometry of the line in a question based on the circle. And you might find that it does help, and it helps hugely to draw diagrams of these things in order to get an idea of where the points might be and how to tackle the question. Okay, let's keep going. Let's take the second one. So, as I said to you already, the only other type of circle that exists out there is a circle whose centre is not at 0, 0. So it's somewhere else. It's at HK, okay? And if its centre is at HK, then we have to adjust the previous formula slightly to take in the fact that the centre of the circle is not at 0, 0. And if that's the case, the equation is x minus h to be squared plus y minus k to be squared equals r squared, where h and k are the coefficients of the centre. All right, so just a little step up on what we were doing in the previous one. So let's have a look at this. Find the centres and radius length of each of the following. Now, in this case, they want me to work out where is the centre and what's the length of the radius. Now here's what you notice. X and y are both being adjusted. X minus 5 to be squared, y plus 2 to be squared. Okay, and that's equal to 81. So from here immediately I know that the centre is not 0, 0. Because if it was 0, 0, x squared and y squared would be on their own. But because x has been adjusted by minus 5, and because y has been adjusted by plus 2, the minus 5 and the plus 2 are minus h and minus k. So I would basically always write up the equation over it. So I know that this has the form of the second type of equation, x minus h to be squared and y minus k to be squared equals r squared. So immediately what do I know? I know minus h is equal to minus 5. So minus h equals minus 5. And here minus k equals plus 2. So I'm just reading down this way. Minus h equals minus 5. Forget the x's, don't worry about them. Minus h equals minus 5. Forget them. Minus k equals plus 2. Now from there, I'm going to get the centre. Because the centre is hk, all right? Which means if minus h is minus 5, h will be 5. And if minus k is 2, then k will be minus 2. So there's your centre. And the radius is found in exactly the same way as previous. It's the square root of the final number, which is 9. What about this one here? Now here's what I want you to notice. The x squared is being left alone. There is no change in the x. And because there is no change in the x, that is telling me straight away that the first part of the centre of the circle is 0. X squared has no adjustment. There's no, put it this way, there's no minus h after it, all right? So it's just x squared, which brings us back to the previous formula. X squared plus y squared equals r squared. If it's x squared plus y squared equals r squared, the centre is 0, 0 for both x and y. Here, x squared tells me that the x coordinate of the centre is 0. And this one here, take out your minus 3 and change its sign, and it becomes plus 3. And what's the radius? The radius is nothing more than the square root of the last number, which is root 5. Now, off the top of your head, do you know what root 5 is? No, neither do I. Who cares? We don't have to find it. Leave the radius as a third, okay? So, two things I want you to remember. Leave fractions alone if they appear. If you're going to use them in a question, try and get rid of them. But if they appear as an answer, leave them. Don't bring them to decimal form. And secondly, if your answers come out in third form, leave them as third form. It's the most accurate way to represent that particular answer. Okay, now I think there is another question underneath this one. There is. So let me just clear off this stuff here. We'll just get rid of all this very quickly. And then we'll take a look at the questions underneath them. So that's how you get the centre and the radius. Quite an easy thing to do. Just to read them from the equations in which they are in. The key thing is for you to be able to identify, is the center at 0, 0, or is the center somewhere else? That's the key thing. Okay, look at these two. What is the x-intercept and the y-intercept of the following circle? X plus 5b squared plus y minus 8b squared equals 164. Now, what did we say about the x-intercept? The x-intercept means that you remove any reference to y. So the x-intercept means no y, and the y-intercept means no x. Okay, so let's take this equation here and let's rewrite it first of all with no y. So let's get the x-intercept. What happens? We rewrite this equation with no y. So we're going to get x plus 5 to be squared plus, leave out the y, minus 8 to be squared equals 164. Okay, now we know already that minus 8 squared is 64. So here's what we end up with. I'm just going to bring it up here. We end up with x plus 5 to be squared is equal to 100. All right, for the very simple reason that minus 8 squared is 64, so you can take 64 from both sides, reduce both sides of the equation by 64, and you end up with x plus 5b squared equals 100. All right, now what do they want me to do? They want the x-intercept, so they want me now to solve for x. So look, I can do this in two easy ways. First of all, I can take x plus 5 to be squared. Let's get the square root of both sides. X plus 5 equals. Now, let's just make sure we understand that when you're getting the square root of 100, there are two answers. It's plus or minus 10. So the first equation would be x plus 5 equals 10, which means x is equal to, bring that over here, 5. The second equation would be x plus 5 equals minus 10, which means in this case x equals minus 15. So therefore the x-intercept there is 5, 0, and the x-intercept here is minus 15, 0. All right, so just be careful that when you're using square roots, always remember square roots have two answers. It's the positive and the negative of the root that you're going to be using. So there's your two intercepts. What about the y-intercept? So let me just go back there. Let me take off that. Okay, so let me just take that off. Now I want to get the y-intercept. So what am I going to do? There's going to be no x. So just take out reference to x, and you end up with 5 squared plus y minus 8b squared is equal to 164. Now do the same thing as before. 5 squared is 25. So let's take 25 away from both sides. 164 minus 25, and that comes out as 140. It's unusual, but it comes out as 140. So I get y minus 8b squared equals 140. Okay, now that's going to give me two equations. The first equation it'll give me is y minus 8 equals the positive root of 140, and then the second equation will be y minus 8 equals the negative root of 140. And in this case, you can work these out via the calculator. So in the first case, y equals, so you're going to get the square root of 140, and you're going to add on 8. And that comes out as 8 plus 2 root 35. 8 plus 2 root 35. And here, you're going to get the negative square root of 140. And you're going to add on 8 again. And that's going to come out now as 8 minus 2 times root 35. So they happen to be your y-intercepts, which means the points will be no x and 2 root 35. Sorry, 8 plus 2 root 35, and then the second one will be 0, no x, comma, 8 minus 2 root 35. And again, as I said to you already, leave them in surd form if the surd form exists. Don't move to decimals. The only time you ever move to decimals is when you're explicitly told to do so. And that's going to be the same for anybody who does maths in college. They'll always tell you, stay away from decimals. Give your answer in surd form, give your answer in fraction form, but do not give your answer in decimal form unless you're explicitly asked to do so. Okay, so let's take another worked example here. This time we're using a centre that is outside of 0, 0. So the circle Z shows the diagram, in the diagram, has a diameter endpoints minus 1, 4, that's here, Z, and 3 minus 2, which is here. They want me to find the centre of Z. Now look, to find the centre of Z, I'm simply going to find the midpoint of that line. So I'm going to use the midpoint formula. And the midpoint formula is, as you already remember, x1 plus x2 over 2, comma, y1 plus y2 over 2. That comes from the previous chapter. Now take your points and put them in carefully. This is x1, y1, and this is x2, y2. Okay, shove them in, let's see what happens. Let's see what we get. We get, add the x's together. Minus 1 plus 3, that's 2. 2 over 2 is 1. And then here, 4 minus 2 is 2, divided by 2 is 1. So 1, 1 appears to be the centre, and let's see if that's correct. So there's 1, and then 1 would be around here somewhere. Yeah, it appears that's exactly where it is, 1, 1. Okay, so 1, 1. I'm just going to check that again. Minus 1 plus just 2 divided by 2, and 4 minus 2 is 2. Yeah, 1, 1, that's the centre. Done. Find the radius length. Now, if the centre is 1, 1, let me just say 1 is here. So if the centre is 1, 1, how do I get the length of the radius? Well, if that's the centre, you can take that as being a radius, or you can take that as being a radius. So just make sure that you point out the radius is between 1, 1 and, let's say, 3 minus 2. Now, it doesn't matter which of the two endpoints you use because the radius will give you the same length. So now, if I want the length of the radius, I use the distance formula. And the distance formula is equal to the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. Okay, so fill it in. What that become? x2 minus x1 to be squared. So that's going to be 3 minus 1 to be squared, which is 2 squared, which is 4, plus y2, so minus 2 minus 1, which becomes minus 3 squared, which is 9. And that gives me root 13. Okay, let me just take a little bit off the top of that there, it's too long. Okay, so root 4 plus root 9. Let me just check that again. So x2, so that's 3, minus 1 is 2 squared is 4, and then minus 2 minus 1 is minus 3 squared is 9. So you get root 13. And the last thing it says is write down the equation of z. Now, is it x squared plus y squared equals r squared? Or is it x minus h to be squared plus y minus k to be squared equals r squared? That all depends on where the position of the centre of the circle is. Here, the centre is at 1, 1, so it is not at 0, 0. So that means we're going to be using the equation of a circle, which is x minus h to be squared plus y minus k to be squared equals r squared. Now what's hk? The centre. hk is the centre of the circle. Okay, so hk is equal to the centre, which is 1, 1, and the radius is equal to root 13. So all I've got to do now is take those two and put them in here. Now notice when h and k go into the formula, their signs change. So the equation becomes x minus 1 to be squared plus y minus 1 to be squared is equal to root 13 squared, which is 13. And that's the equation of the circle. That's it. Now again, relatively straightforward, relatively simple. The only difference between that question and the one I did before was the centre of the circle was not at 0, 0. So therefore we had to adjust the x and the y by h and k. Okay, so let's take a look at this. Find the equation of the circle having the lines x plus 1 equals 0 and x minus 3 equals 0 as tangents, and with its centre lying on the line y equals 3. Okay, there's a lot going on here. All right, so let's take a look first of all and see what would it look like. So we've got a x-y axis like that. We've got a circle whose centre lies on y equals 3. So y equals 3, that's a line going through this way here. So its centre is somewhere there. But we're also told x plus 1 equals 0 and x minus 3 equals 0 are tangents. Now just watch what I'm going to do here. Let's take this one first of all. X plus 1 equals 0. And then x minus 3 equals 0. Just rearrange that. X equals minus 1, x equals 3. They happen to be the tangents of the circle. So x equals minus 1 would be here, and x equals 3 would be here. So therefore, that line running through there and that line running through here are both tangents to the circle. So now I have an idea what my circle looks like. See that? Now that's what you've got to be able to do, and that comes from the previous chapter. I now have an idea as to what my circle looks like, and that's the key thing. All right, now first of all, this is x equals minus 1 and this is x equals 3. We already know that this is on the line y equals 3, so that's trying to tell me that the y coordinate of my centre is going to be 3. To find my x coordinate, the x coordinate is simply halfway between minus 1 and 3. Now, minus 1 to 3 is 4 units. Half of that is 2 units. So therefore, it's 2 units up from from minus 1, which brings me to plus 1. So the diagram alone helped me to get the centre of that particular circle. Okay, watch it again. If the centre of the circle is on the line y equals 3, then its y coordinate will be 3. Okay, how do I get the x coordinate? Well, I'm told that x plus 1 equals 0 and x minus 3 equals 0 are tangents. So if they're tangents, just to rearrange the equations, the tangents are actually x equals minus 1 and x equals 3. Now, x equals minus 1 is a line that runs through minus 1 on the x-axis, and x equals minus 3 is a line that runs through the value 3 on the x-axis. So therefore, if there are 4 units between those two, then the middle of that, where the actual centre circle is, will be 2 units away from either end. So you could say it's 2 units down from 3, or it's 2 units up from minus 1. Either way, you're going to get the x coordinate of 1. So what does it ask? Find the equation of the circle. Well, here's what I do know. The centre is now, of this circle, is 1, 3. Okay, so I immediately know that the equation I'm going to use is x minus h to be squared plus y minus k to be squared equals r squared. I know that. All I've got to do now is work out the length of the radius. But the length of the radius is going to be very simple, because the length of the radius is going to run from x equals 1 to x equals 3. The length of the radius is 2. We already worked that down there. Okay, so that gives me a radius of 2, because the radius is from the centre of the circle to the outside. So if there's 4 units running across this way, 2 of them, if the diameter is 4, then the radius has to be 2. So if the radius is 2 and the centre is 1, 3, what does that mean? Let's put the radius up here. You take these two into that formula, and here's what you get. X minus 1 to be squared plus y minus 3 to be squared is equal to 2 squared, which is 4. That's the equation of the circle. Okay, more questions for you. These are only 1 or 2 parts of different questions. Page 298, question 1, 2 and 3 and 10. And that will get you to work with questions that involve the centre of a circle being somewhere else. Okay, the final part, and I just want to deal with this and then we'll stop. The final equation we're dealing with is the expanded form of the equation. Now this thing here actually has a name. This is called the general formula of a circle. Okay, that's the general formula for a circle. And what that means is that every circle, doesn't matter if its centre is 0, 0 or hk, every circle can be written in this form. So that's the expanded version of all circles. What is unusual about this is the fact that the centre is hidden in here and the radius has to be calculated. The centre is half the coefficient of x with its sign changed and half the coefficient of y with its sign changed. And the radius is then the centre coordinate squared and added together, and then you take away the final constant at the very end. So let's just use that. A circle has centre 4 minus 2 and radius length 5. Find the equation of the circle in the form x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Okay. So the first thing I've got to remember here is that it has a centre of 4 minus 2. Now in that case, when we're dealing with the equation in this form, here's what we've got to remember. The centre of a circle in this form is minus g minus f. Okay? And as we know then, the radius is equal to the square root of g squared plus f squared minus c. Now, a little bit of work involved in this one. So straight away, here's what we do know. That if minus g is equal to 4, well then g must be equal to plus 4. And if minus f is equal to minus 2, well then f must be equal to 2. So we have our g and our f. So that's sorted and that's sorted. What is not sorted is c. But here's what I know. The radius length is 5. Now, because we're dealing with this form of the equation, that means that the radius of g squared plus f squared minus c is equal to 5. So I'm going to fill in g and f because that's all I do know. I have to work out the value of c. G squared is 16 because it's 4 squared. F squared is 4 minus c. So the square root of 16 plus 4 minus c is equal to 5. Square both sides. You get 20 minus c is equal to 25. See that? So 20 minus c is equal to 25. So you're squaring both sides. And that means that minus c is equal to 5. I'll put that another way. C is equal to minus 5. And now I have everything I need. There's my g, there's my f, and there's my c. Now write it out. X squared plus y squared plus 2gx. So that's going to be 8x. Plus 2fy. That's going to be 4y. Plus c, which is minus 5, is equal to 0. And that is the equation of my circle. Okay, so again, go over that in your heads, make sure you understand the steps behind it, see where I'm getting those values from using the formulas above, and then we just apply them to the general form of that particular circle. Okay, so there's one more down here. What is the center and radius length of a circle with equation 9x squared plus 9y squared minus 6x plus 18y plus 1 is equal to 0? Okay, the answer is at the moment this equation is unreadable, because if you go back to the top of the slide, the equation must begin with x squared and y squared. There is no other coefficient allowed of x squared and y squared, only one. So the very first thing I have to do here is I have to divide it across by 9. And that's going to give me the required x squared plus y squared. Now that's good. Minus 6 over 9x plus 18 over 9y plus 1 over 9 equals 0. Okay, now we do know if I want to simplify that down, that's going to become x squared plus y squared. Now 6 over 9, that's like 2 over 3x. 18 over 9, that's 2y plus 1 over 9 equals 0. Remember what I told you? Stick with the fractions. Do not go to decimal form. Stick with the fractions and see what they tell us. So in this case, x squared plus y squared plus 2gx plus 2fy is equal to plus c is equal to 0. So straight away, if I follow this thing here, what does it tell me? That the coefficient of x is 2g. So 2g is equal to minus 2 over 3. Okay. 2f is the coefficient of y. So 2f is equal to 2. And c is equal to 1 over 9. So let's work this out. G is equal to minus 2 over 6, because I divide both sides by 2. F is equal to 1, and C is equal to 1 over 9. So now I have the equation. Now I can write it out. What's the center? The center is minus G minus F. So therefore the center is equal to minus G, which is a third, minus F, which is minus 1, and the radius length will be, and we've got to work this out, where's the square root of g squared plus f squared? Actually, I'm going to do it up here. Let me just do it up here, bit of space. Let me just take the radius up here, all right? So the radius is equal to the square root of g squared plus f squared minus c. So let's fill in the values. G squared, well, what's g? It's 2 over 6, so it's 1 over 3. Squared, that's 1 over 9. Plus f squared is 1 minus a ninth. Aha, a ninth and a ninth cancel. See why it's so important to stick with fractions? And you get the square root of 1, which is 1. So what's the center? Third minus 1. And what's the radius? Answer 1. You need practice on those formulas, okay? I need a lot of practice on those formulas. So let me just work on this, and I'm going to give you some questions to do yourselves. Page 303, question 9. The circle x squared plus y squared minus 2x minus my minus n equals 0 contains the points 2, 1, and 1 and minus 1, 2. Find the value of m and the value of n. Now, m and n, they're asking you to get two variables. If you're asked to get two variables, you're going to be using a pair of simultaneous equations. So, if the circle contains the points a and b, then what that means is that you can put a into the equation for x and y, and b into the equation for x and y, and see what we have. Okay, so let's take a look at this. Do it down here. At a, which is 2, 1, what am I going to do? I'm going to plug this into the formula up here. 2 squared is 4, 1 squared is 1, minus 2x, that's minus 4x, minus my, oh sorry, that's minus 4 I should say, as the x is gone. Let me just do that again very quickly. Let me do that again. I'm going to start again. Okay, so let's do it again. So we're going to put 2, 1 in there. So at 2, 1, what happens? 2 goes in for x, that becomes 4. 1 goes in for y, that becomes plus 1. Minus 2 2's, that's minus 4. Now y goes in there, that's minus m minus n equals 0. So straight away they cancel, and that leaves you with minus m minus n equals minus 1. Or put that another way, m plus n equals 1. So there's your first equation. Okay, m minus n plus 1 is equal to 0. Yeah, so there's your first equation. That's equation 1. Okay, at the point minus 1, 2. Now take your time. So put minus 1 in for x. Minus 1 squared is 1. 2 squared is 4. Minus 1 goes in there to give plus 2. 2 goes in there to give minus 2m. And then we have minus n equals 0. So from that equation, what do we get? We get 4 and 2 is 6 and 1 is 7. So we get minus 2m minus n plus 7. So bring it over to your side, minus 7. So that becomes 2m plus n equals 7. And that's equation number 2. And there's my pair of simultaneous equations. That's it. So all I've got to do now is take them. 2m plus n is equal to 7. And m plus n is equal to 1. And we're going to change the signs on the bottom line here. And that's going to give me m equals 6. And once I've discovered what m is, I take that back up here. And this is, I'm doing this quickly because this is from the previous chapter. So take 6 back up here if you want to, or take it into any one of the original equations, because it says if we put 6 into this equation here, into m plus n equals 1, it becomes 6 plus n equals 1. N is equal to 1 minus 6, so therefore n equals minus 5. That's it. So there's your value of m, and there's your value of n. So again, something that we've got to remember. If points are on a circle, if the circle contains a point, then you can put the point into the equation of the circle and it will satisfy that equation. Okay, final example. Find the value of t, element r, such that 1t lies on the circle x squared plus y squared plus 4x plus 8y plus 11 equals 0. Same thing again. If that point lies on the circle, then at the point 1t, this equation will be satisfied. So all we do is take the two values and shove them into the equation. 1 squared is 1, t squared is t squared, 4 1s are 4, minus 8t is minus 8t, plus 11 is equal to 0. See what happens? You end up with an equation in t. That's what happens. So you put 1 in for all the x's. That becomes 1 squared is 1. That becomes 4 1s are 4. Then you put t in for y. That becomes t squared. That becomes minus 8t. And you reorganize your equation. And here's what you end up with. T squared minus 8t plus 11 plus 4 is 15 plus 1 plus 16 is equal to 0. All right, and that. So t squared minus 8t, 11 and 4 is 15, and 1 is 16 is equal to 0. Good. So let's see if we have t and t. 16, 4, and 4. And we want 2 minuses in there. So there is only one value. And that is that t minus 4 is equal to 0, which means t is equal to 4. So t squared, t by t. Factors of 16 that add to 8. Well, that's obviously 4 4s, but they have to add to minus 8. So it's minus 4 and minus 4. T equals 4. Done. Okay. The last form then is this one here that we spoke about. The last form of x squared plus y squared plus 2gx plus 2fy plus c equals 0. Here's what we learn. Okay, and this has got to do with all three circles. These 3 points are extremely important. The coefficients of x squared and y squared, they must be equal. So in other words, you're not going to have this 16x squared plus 5y squared. That's not going to happen. You're never going to have that. The coefficients of x and y must be equal. However, the coefficients of x squared and y squared must be 1. I'm going to put it in there. Must be 1. And if it's not 1, if the coefficient of x and y is not 1, then you divide across by whatever number you need to divide across by to get the coefficient of x squared and y squared down to 1. The highest power must be 2. Now, because the x squared and y squared have powers of 2, they're both curving. And because they're both curving, see what happens? They form a circle. So the x squared and the y squared is important in giving that circular structure. And lastly then, there must be no xy term. They must be written in terms of x and y, but never in terms of xy. Okay, remember, as we said already, to work with a circle's equation, one must be the coefficient of x squared and y squared. So in other words, the example there, 5x squared plus 5y squared equals 75, can't do it. You divide everything across by 5 and then you use the equation. Okay? Okay, let's take a look at these. And this is just going to wrap up what we were doing, and that's going to finish off with questions then like that as far as, yeah. I'm going to finish with these questions here. Okay, so we're going to finish on this slide. What is the centre and radius of each of the following circles? Now watch what I'm going to do here, because I can read these. X squared plus y squared equals 25. Immediately, centre, 0, 0. How do I know that? Because x and y have no adjustments. X squared plus y squared. There's no numbers hanging off them, okay? There's no mention of h, there's no mention of k, there's no mention of g, there's no mention of f. So it's centre 0, 0. What's the radius, therefore? Square root of the last number. Radius is equal to 5. What about this one? Now, we can't use this as it stands because it starts off with 16x squared, 16y squared. So before I read anything, the first thing I've got to do is divide across by 16. That will give me x squared plus y squared equals 25 over 16. And now I know the centre is 0, 0, because again, x squared and y squared are on their own. And the radius is the square root of the last number, which is 5 over 4. Okay, next one. Now you'll notice x and y are both adjusted, okay? So this follows x minus h to be squared plus y minus k to be squared equals r squared. And again, you can read off the centre. The centre, in this case, is if minus h is equal to plus 3, then h must be equal to minus 3. If minus k is equal to minus 5, well then k must be equal to plus 5. So there is your centre. And the radius is again nothing more than the square root of the last number. Radius is 7. Now in this case, last two cases, a little bit of calculation. First of all, we've got this situation where we've got x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So it follows that, meaning that my centre is going to be equal to minus g minus f. Now, if 2g is equal to 8, then g must be equal to 4, so minus g must be equal to minus 4. If 2f is minus 10, then f must be minus 5, so minus f must be plus 5. And the radius has to be calculated, because the radius is g squared plus f squared. So you take the coefficients of the centre and you square both of them. 16 plus 25, and then you take away the last number, which is the last constant, and that's going to give you the square root of 16 plus 25 minus 7. 16 plus 25 minus 7, which works out to the square root of 34. Leave it. That is the radius. Square root of 34 is the radius. And lastly then, 3x squared plus 3y squared minus 12x plus 6y minus 21 equals 0 doesn't follow any equation, because all the equations have to begin with x squared and y squared. So the very first thing I'm going to do here is divide everything across by 3. X squared, y squared, 4x, 2y, minus 7 equals 0. And now I can read off the centre and the radius. So again, write down the template. What does it follow? It follows 2gx and 2fy minus c, plus c, is equal to 0. So just follow that. What's the centre? The centre is as follows. Watch. If 2g is minus 4, then g must be minus 2, so minus g must be plus 2. See that? If 2f is plus 2, then f must be plus 1, so minus f must be minus 1. And again, the radius is equal to the square root of both of these squared. 2 squared is 4, 1 squared is 1, minus the final constant, which is minus 7, which is plus 7, giving me the square root of 8 over 12. And again, leave it as the square root of 12. So the centre is 2 minus 1, and the radius is root 12. Okay, now I want you to try out page 298, question 1. Look, go back over all of those slides. There's quite a number of questions I want you to do, and I want you to get through them. Do those questions today in maths time, see how you get on with them, and then we'll take it up from there in the next class, and we'll move on into how we look at points that are inside, outside, or on a circle.